Icy dwarf planets at the edge of our solar system may harbor subsurface oceans. Beyond the orbit of Neptune, away from the heat of the Sun's rays, there is a vast region in which countless smaller and larger objects orbit. This is the Kuiper belt. There are also dwarf planets. On two of them, Eris and Makemake, astronomers have recently detected traces of geothermal activity. The Kuiper belt is a vast area beyond the orbit of Neptune, at the edge of the solar system. It contains millions of smaller and larger objects that are believed to be remnants of the formation of the solar system. In addition to space debris, there are also dwarf planets orbiting there. The largest of them is Pluto. It is also the brightest object in the Kuiper belt. Until now, it was believed that objects located so far from the heat of the Sun were cold and dead bodies. But appearances can be deceiving. Astronomers using the James Webb Space Telescope, JWST, have found evidence of hydrothermal activity on the icy dwarf planets Eris and Makemake, located in the Kuiper belt. The description and results of the research were published in 2 publications in the magazine, Icarus. Eris is comparable in size to Pluto. Makemake is slightly smaller. However, these worlds orbit the Sun at a much greater distance than Pluto. Both dwarf planets, like Pluto, show evidence of oceans beneath their frozen crusts. These bodies probably formed early in the history of our solar system, about 4.5 billion years ago. In new research, astronomers have spotted traces of high-temperature phenomena taking place beneath the icy shells of these dwarf planets. We're seeing some interesting signs of hot phenomena in cold places, said Dr. Christopher Glein of the Southwest Research Institute, lead author of the paper. I entered this project with the idea that large Kuiper belt objects, KBO, editor's note, should have ancient surfaces filled with materials inherited from the primordial solar nebula, because they can retain volatile substances such as methane. Instead, the James Webb Space Telescope gave us a surprise. We found evidence of thermal processes producing methane inside Eris and Makemake, he added. In newly published work, a team of astronomers with the help of JWST measured the surface composition of dwarf planets, in particular the ratio of deuterium, heavy hydrogen, D, to hydrogen, H, in methane. Deuterium is believed to have been created during the Big Bang, and hydrogen is the most abundant element in the universe. The ratio of deuterium to hydrogen on a planetary body provides information about the origin, geological history, and formation pathways of hydrogen-containing compounds. The moderate deuterium to hydrogen ratio we observed with JWST contradicts the presence of primordial methane on the ancient surface. Primordial methane would have a much higher ratio of deuterium to hydrogen, Glein said. Instead, the ratio of deuterium to hydrogen points to the geochemical origin of methane, which is likely produced in the interior of dwarf planets. The ratio of deuterium to hydrogen is like a window. We can use it to look beneath the surface. Our data suggest that the rocky cores of these worlds are at elevated temperatures, which could produce methane. Molecular nitrogen, N2, can also be formed there, as we see on Eris. The hot cores of these objects may also indicate the presence of liquid water beneath their icy surfaces, Glein emphasized. Icy worlds may be subject to much greater evolution than previously thought. Evidence of subsurface oceans has been found on several icy moons, such as Saturn's moon Enceladus and Jupiter's moon Europa. Liquid water is one of the key ingredients determining the potential for the existence and development of life, at least as we know it. Scientists suggest that other cold, icy worlds may also have warm interiors. If geothermal processes were, or perhaps still are, occurring in the rocky cores of Eris and Makemake, then cryovolcanism could have delivered methane to the surface of these dwarf planets, perhaps in geologically recent times, said Dr. Will Grundy of Lowell Observatory, co-author of the paper. We found that the carbon isotope ratio, 13C, 12C, suggests its recent appearance on the surface, he added. After New Horizons flyby of the Pluto system and thanks to our discoveries with JWST, the Kuiper belt turns out to be much more alive with dynamic worlds than we would have imagined. It's not too early to start thinking about sending a spacecraft to fly past one of these bodies to put the data collected by JWST into geological context. I believe we will be stunned by the miracles that await us, Glein said. The Japanese SLIM lander survived the moonlit night. Contrary to expectations, the SLIM probe on the Moon managed to survive the difficult lunar night. The Japan National Space Agency, JAXA, announced that it managed to establish communication with the lander. A Japanese lander delivered a surprise by waking up after a 2-week lunar night. On January 19, SLIM landed on the lunar surface. However, the landing, although it was the most precise landing on the silver globe in history, was not entirely successful. Due to problems with the solar cells misaligning and thus generating power, SLIM was disabled. After a few days, when the angle of sunlight changed, SLIM came to life, but only for 2 days. During this time, the mission managers carried out planned observations and performed some research. As the moonlit night came, the lander fell asleep again. The lander's designers did not prepare it for the extremely difficult conditions of a lunar night, but the Japanese equipment showed what it was capable of. According to JAXA, it managed to establish communication with the lander. Everything indicates that the mission, already written off as a loss, will be continued. During the lunar day, temperatures on the surface of our natural satellite can reach over 120 degrees Celsius, but at night they drop to minus 130 degrees C. These are difficult conditions. especially since both night and day on the Moon last 14 Earth days. The moonlit night was the cause of death for many robotic missions. But the SLIM probe managed to survive. Yesterday we sent a command to which SLIM responded. The probe managed to survive the night on the lunar surface while maintaining its communication function. JAXA reported on the X platform, formerly Twitter. The message went on to admit that communication was interrupted because temperatures had risen significantly with the arrival of the lunar day. And it was now midday there, and the temperature of the communication equipment was very high. Preparing to resume operation once instrument temperatures have cooled sufficiently, JAXA said. The SLIM probe was built, among others, to demonstrate a new navigation system capable of precision landing on the lunar surface. That's why the lander was also referred to as the lunar sniper. Analysis of the data obtained before the power was turned off confirmed that SLIM landed approximately 55 meters east of the destination, and not as was the case in previous attempts, which ended several dozen kilometers from the designated location. The news that SLIM has restarted after a cold lunar night is significant, said Dr. Simeon Barber of Britain's Open University. Surviving the lunar night is one of the key technological challenges that must be overcome if we are to organize long-term robotic or manned missions on the Moon, he added. He also explained that SLIM landed near the Moon's equator, where at lunar noon the surface reaches over 100 degrees Celsius. According to Barber, future lunar landers will need active thermal control, the ability to dissipate heat during the day and then switch to a heat-saving mode at night to prevent cooling. The fact that SLIM survived may give us clues about how electronics actually behave on the Moon, Barber said.